All right, you guys, this is Concentrations and Dilutions lecture video number 4. And I am going to pick back up with practice problems A on page 524. And we're going to look at number 2. Number 2 reads, how many milliliters of 10% solution can be made from 750 grams of a chemical? All right. So the first question that you ask yourself, number 1, what type of problem is this? Okay, is it concentration, dilution, or alligation? Well, of course, because you guys, we've only talked about concentrations, your answer would be concentration. But in detail, you know it's a concentration problem. It's a concentration problem because within this problem, you only see one concentration, which is expressed in a percentage. If it has more than one concentration, if it has 2 concentrations, regardless of how it's expressed, whether it's a ratio, a fraction, or a percentage, it's a dilution problem. If it has 3 concentrations, all right, whether it's expressed as a percentage, a fraction, or a ratio, it's an alligation, all right, problem. So with that being said, now that you know that it's a concentration problem, the next question you ask yourself is, what type of concentration is it? What type of concentration is it within this problem? Well, in order to figure that out, you have to read the problem. It says how many milliliters of 10% solution can be made from 750 grams. If it's milliliter in grams, all right, you ask yourself, out of those 3 types of concentration, you have weight to weight, weight to volume, and volume to volume. Which of the 3 does this problem match? Well, your answer would be that it is a weight to volume problem, because the problem gives you 750 grams and you're looking for what? Your milliliters. You don't know what that number is. So you know that this is a weight to volume problem. So the next question you ask yourself is, what is it that I'm looking for? Well, you know that you're looking for the amount of milliliters. But in detail, based off of the formulas, you are looking for the total. Because remember, if it's active, your active will be what? Your top number. Your total will be your bottom number. You have an active. Your active is 750 grams, but you don't have a total because you're looking for the milliliters. So in order to solve this problem, you're going to use that formula where you take your active, which is 750 grams, over X equals the percentage, which is 10%, which is 10 over 100. And we can continue to solve this by crisscross multiply. So that is 10x equals 75,000, because 750 times 100 is 75,000. You're going to divide 10 on both sides, and x equals 7,500 milliliters. And we know that my unit should be in milliliters because that is what I'm looking for, is how the total amount of milliliters. So we have solved number 2 for practice problems A on page 324. All right, let's try another problem. Let's look at number 3 on page 525. The very next page. They want to know how many milliliters of 10% methyl salicylic would be necessary to prepare 3 pints of 4% lotion. All right. Well, we already know that the type of problem this is a concentration problem, because I'm wrong on this one, you guys. This is actually a dilution problem. Why is it a dilution problem? Because you've been given 2 concentrations. Remember, I told you, if it's 1 concentration, regardless of how it's being expressed, whether it's a percentage, a ratio, or a fraction, it's a concentration problem. If you're given 2 concentrations, regardless of how it's being expressed, whether it's a percentage, a ratio, or a fraction, it's a dilution problem. If you are given 3 concentrations or 3 strengths of a medication, you know that it's an alligation problem. And it doesn't matter how the concentrations come, whether it's expressed as a ratio, a fraction, or a percentage. This is still the rule when solving these problems. So technically, we are going to skip number 3 for right now because I haven't gone over dilutions. All right. And there's a totally different way of solving this. I'm going to skip on to number 4. Same page, but it says if 15 milliliters of peppermint, just put peppermint oil, is in 500 milliliters of a solution, what is the percent strength of the fluids? Alrighty. So the first question you ask yourself is, what type of problem is it? Is it a concentration, a dilution, or an alligation? If you read this problem again, if 15 milliliters of peppermint oil is in 500 milliliters of a solution, what is the percentage strength of the fluids? Well, some of you guys will say that this is neither because I don't see a concentration. Well, that's because you're looking for the concentration. We are looking for the percent strength. So you know that this is a concentration problem because number 1, they're asking us to find this one concentration. There's no other concentrations listed there. All right. So it's a concentration problem. Number 2, you ask yourself what type of concentration is it? You have 15 milliliters of peppermint oil that's in 500 milliliters of a solution. So that means the type of concentration is what? It's milliliter per milliliter, which means that it's volume per volume type of concentration. Well, in order to solve this problem, you're going to have to use one of those 3 formulas I gave you. Because you're looking for the percent strength, you're going to have to take your active over your total and multiply it by 100. So you're going to take 15 milliliters over 500 milliliters and multiply it by 100. That's going to give you your percent for this medication. This is how they determine the strengths of medication in the percent form. Your answer is 3%. All right. I think we could try another one. Let's see what we can do. Let me go back up to the top of the page here and erase what I've gotten up here for you guys. The goal is to erase it all. So I think we just answered number 3, I believe. Let's look at, or I think that was number 4. Yes, that was number 4. Let's look at another one. Skip down to number 7. And number 7 reads, how many grams of boric acid would be necessary to prepare 60 milliliters of a 5% solution? All right. How many grams of boric acid would be necessary to prepare 60 milliliters of a 5% solution? So number 1, you're going to ask yourself, what type of problem is it? Well, you only have one concentration listed. So this is a concentration problem. So then you ask yourself, well, what type of concentration is it? If you are looking for how many grams are within 60 milliliters, so that means that the concentration is grams per milliliter, but in detail, that is weight per volume. The type of concentration is weight per volume, and its units is grams per milliliter. All right. Let me keep going. So then the next question you ask yourself is, what is it that we're looking for? All right. Well, you're looking for the amount of grams. If you're looking for the amount of grams and the grams is the weight, then that means you're looking for your active. So the formula that you will use for that, if you're looking for your active, is X over your total, which equals your percent. All right. So again, I'm looking for my active because it's asking me how many grams of boric acid do I need, all right, that are necessary to prepare 60 milliliters of a 5%. How many grams of boric acid? So that means I'm looking for my active. So in order to solve that, again, it's X over your total, which is the volume of the solution, is 60 milliliters, equals 5 over 100. That's your percent. And you have to set it up as a fraction, which is 5 over 100. So you're going to crisscross multiply. So that's 100x, 5 times 60. You guys should have, what, 300? Make sure my math is right. And then you're going to divide 100 on both sides. And x equals 3 grams. That is the answer for number 7. You're going to need 3 grams of boric acid in order to prepare 60 milliliters of a solution that has a concentration of 5%. All right. I'm going to close it out here for lecture video 4, and I'll pick back up and we're going to talk about dilutions.